Zorro Ranch, the genetic factory of a modern Frankenstein. When the scandal surrounding American financier Jeffrey Epstein exploded across the globe, public attention focused on his private island and the powerful names linked to it. Yet some of the most unsettling allegations were tied not to the Caribbean, but to a vast, isolated property in New Mexico known as Zorro Ranch. Spread across thousands of acres in a remote desert landscape, the estate became the subject of reports suggesting that Epstein harbored extreme ideas about genetics, reproduction, and legacy. According to media investigations and witness accounts, he spoke openly about plans to father a large number of children, believing that passing on his own DNA on a massive scale would somehow shape the future. These claims, while often sensationalized, reflected a documented interest in controversial theories surrounding transhumanism, eugenics, and cryonics. Epstein was known to fund scientists and academics across a range of disciplines, including genetics and artificial intelligence, sometimes under opaque financial arrangements. He reportedly discussed the possibility of preserving his brain after death in hopes that future technology might allow some form of revival, an idea associated with speculative cryonics movements rather than established medical science. While no evidence has surfaced proving the existence of a literal genetic factory, the combination of immense wealth, intellectual ambition, and ethically troubling ideology created a narrative that blurred the line between scientific curiosity and personal obsession. Looking across the stark desert terrain of New Mexico, Zorro Ranch stands today as a symbol of how power and money can intertwine with radical ideas about human improvement and immortality. The story serves less as science fiction and more as a cautionary example of what can happen when unchecked influence meets fringe philosophies. In the modern world, the pursuit of longevity and genetic advancement is often conducted in laboratories and research institutes. But without ethical boundaries and transparency, even legitimate scientific fields can become entangled in dangerous visions of control and legacy. Parabiosis, young blood and the anti-aging industry. For centuries, legends have told of creatures who could steal youth by consuming the vitality of others. While such tales belong to Gothic fiction, modern science has explored a real biological phenomenon known as parabiosis, a laboratory technique in which two organisms share a circulatory system. In controlled animal studies, particularly with mice, researchers observed that exposure to younger blood appeared to influence certain markers associated with aging. These findings sparked scientific curiosity about how blood-borne factors might affect cellular repair and regeneration. In the mid-2000s, that curiosity spilled into the private sector. Several startups began marketing plasma transfusion services to wealthy clients, suggesting potential anti-aging benefits despite the lack of conclusive clinical evidence. One of the most widely reported companies, Ambrosia, offered plasma infusions sourced from young donors, charging thousands of dollars per session. The business drew intense scrutiny from regulators and the medical community, and in 2019, the U.S. Food and Drug Administration publicly warned that such treatments had not been proven safe or effective for anti-aging purposes. Shortly afterward, the company ceased operations. The broader scientific community remains cautious. While research into aging biology, regenerative medicine, and plasma proteins continues in legitimate academic settings, experts emphasize that translating mouse experiments into human therapies is extraordinarily complex. No peer-reviewed clinical trials have demonstrated that transfusions from young donors can reverse aging in healthy adults. Moreover, plasma transfusions carry real medical risks, including immune reactions and infections, when used outside established medical indications. The fascination, however, reveals something deeper about our era. In technology hubs and biotech circles, longevity research has become a serious, heavily funded field. Wealthy investors support studies into cellular senescence, gene therapy, and metabolic interventions, not because of mythology, but because aging is a measurable biological process. Yet the line between responsible research and exaggerated commercial promises can blur quickly when vast sums of money are involved. Ultimately, the story of modern young blood therapies is less about vampires and more about ambition. It reflects a society wrestling with the limits of biology, the ethics of medical innovation, and the influence of wealth in shaping experimental treatments. Science continues to investigate aging, but credible progress depends on rigorous evidence, transparent trials, and ethical oversight rather than sensational claims. Cryonics and Alcor Life Extension Foundation, science, speculation, and the quest to defeat death. For centuries, death was accepted as an inevitable biological endpoint. In the late 20th century, however, a small but vocal movement began exploring a radical alternative: cryonics, the preservation of legally deceased individuals at extremely low temperatures in the hope that future medical technology might one day revive them. One of the most well-known organizations in this field is the Alcor Life Extension Foundation, based in Arizona. Founded in 1972, Alcor offers two primary services: whole-body preservation and neurocryopreservation, in which only the brain or head is preserved. The process begins after legal death is declared. The body is cooled, blood is replaced with cryoprotective chemicals intended to reduce ice crystal formation, and the patient is stored in liquid nitrogen at approximately -196 degrees Celsius inside large insulated containers called douars. It is important to emphasize that cryonics is not currently recognized as a proven medical method for future revival. No mammal, let alone a human, has ever been successfully cryopreserved and later revived. Mainstream scientists remain skeptical, citing cellular damage, structural degradation, and unresolved neurological questions. Supporters, however, argue that preservation at the molecular level may retain enough structural information about the brain that advanced nanotechnology or future medicine could, in theory, repair and restore it. Cryonics clients often fund their arrangements through life insurance policies that designate the organization as beneficiary. Long-term financial trusts are structured to maintain storage indefinitely. Whether this represents scientific foresight or speculative optimism depends largely on one's philosophical stance on identity, consciousness, and the pace of technological advancement. Ultimately, cryonics reflects a broader cultural tension, the collision between biological limits and technological ambition. It raises difficult ethical questions about hope, wealth, access, and the boundaries between medical science and existential fear. Mind uploading, digital immortality, and the frontier of neurotech. If cryonics seeks to preserve the biological brain, another branch of speculative research aims to transcend biology entirely. The concept of mind uploading proposes that, in the future, it may be possible to map the complete neural structure of a human brain and simulate it within a digital environment, effectively transferring consciousness into software. While no such technology currently exists, serious discussions around high-resolution brain mapping and connectomics have taken place in academic circles. A controversial startup, Nectomy, drew attention for developing advanced chemical preservation techniques designed to maintain neural structures at microscopic resolution. Critics pointed out that the preservation method required fatal procedures and that the company's public messaging blurred the line between experimental neuroscience and speculative immortality claims. The company later faced regulatory and ethical scrutiny. Separately, initiatives like 2045 Initiative have promoted long-term visions of transferring human consciousness into artificial bodies or digital substrates. These proposals remain theoretical and are widely debated within neuroscience, philosophy of mind, and artificial intelligence research. The core scientific challenge is immense. Consciousness is not yet fully understood. Even if a brain's physical structure could be mapped in atomic detail, it remains unknown whether a digital simulation would constitute the same person or merely a functional copy. Questions about continuity of identity, subjective experience, and moral status remain unresolved. Mind uploading, like cryonics, exists at the intersection of aspiration and uncertainty. It reflects humanity's enduring desire to overcome mortality, but also highlights the profound ethical, technical, and philosophical barriers that stand in the way. For now, digital immortality belongs to the realm of speculative science. The research into brain preservation and neural mapping continues, but revival, uploading, and conscious simulation remain unproven hypotheses rather than achievable realities. Doomsday bunkers, private survival complexes for a crisis-prone world. As concerns about geopolitical instability, pandemics, and climate risks have grown, a niche industry has emerged around high-end survival infrastructure. In the United States and elsewhere, former Cold War missile silos and hardened underground facilities have been converted into luxury shelters, marketed to ultra-wealthy buyers. One widely publicized example is Survival Condo in Kansas, a repurposed Atlas missile silo transformed into a multi-level residential complex. Units reportedly include reinforced blast doors, independent power systems, water purification, hydroponic agriculture, medical facilities, and communal amenities designed for extended isolation. Similar private bunkers have been developed in locations such as South Dakota, Europe, and New Zealand, where stable geography and political isolation are viewed as advantages. It is important to separate documented infrastructure from sensational speculation. While private security arrangements are common in high-net-worth properties, there is no verified evidence supporting extreme claims such as explosive control mechanisms for staff. Most public information indicates that these facilities are structured as shared condominiums with contracted security, emergency planning protocols, and long-term sustainability systems. The broader phenomenon reflects a psychological shift among some wealthy individuals, risk mitigation scaled to existential levels. From backup data centers to offshore financial structures, redundancy has long been a feature of elite planning. Underground shelters represent a physical extension of that philosophy, preparing for low-probability, high-impact events. Whether viewed as prudent contingency planning or as a symbol of widening inequality, luxury bunkers illustrate how wealth can reshape one's approach to uncertainty. They do not guarantee survival in every conceivable catastrophe, but they do reveal how differently risk is experienced across economic strata. Calico, corporate longevity research and the science of aging. For much of human history, aging was treated as an unavoidable biological fate. In the 21st century, however, advances in molecular biology, genomics, and computational modeling have reframed aging as a complex, multi-factor biological process, one that might, in principle, be slowed or modified. In 2013, Alphabet, Google's parent company, launched Calico, California Life Company, with the stated mission of understanding the biology of aging and age-related disease. Rather than marketing consumer therapies, Calico operates primarily as a research organization, collaborating with academic institutions and pharmaceutical partners to study cellular senescence, DNA repair mechanisms, protein homeostasis, and metabolic regulation. Unlike speculative immortality projects, Calico's publicly documented work focuses on extending health span, the period of life spent in good health, rather than guaranteeing extreme lifespan extension. Aging research remains scientifically challenging. While certain model organisms have shown lifespan changes through genetic or pharmacological intervention, translating such findings to humans is complex and uncertain. Concerns about unequal access to advanced medical therapies are legitimate public policy discussions. Breakthrough treatments in many fields, from oncology to gene therapy, often begin as expensive interventions before broader scaling reduces cost. Whether future anti-aging therapies would follow a similar path remains unknown. What is clear is that aging research today is grounded in mainstream biomedical science, not secret immortality programs. The ambition is significant, the funding substantial, and the timeline uncertain. The central question is not whether death can be hacked, but how far human health can be extended responsibly, ethically, and equitably within biological limits. Chimera research, organ growth, xenotransplantation, and bioethics. Modern transplant medicine faces a persistent shortage of donor organs. In response, scientists have explored xenotransplantation, the transplantation of animal organs into humans, and experimental research into growing human-compatible tissues inside animals. The goal of such research is not the creation of organ farms for elites, but addressing critical medical demand. In recent years, genetically modified pigs have been engineered to reduce immune rejection in human recipients. In 2022 and 2023, surgeons performed groundbreaking pig-to-human heart transplants under emergency authorization in the United States. These cases, while medically complex and not yet routine, demonstrated measurable scientific progress in the field. Parallel research has investigated creating human-animal chimeras at early embryonic stages, inserting human stem cells into animal embryos to study development or potentially grow transplantable tissues. These studies are tightly regulated, often restricted to early developmental stages, and subject to extensive ethical oversight. Many countries prohibit allowing such embryos to develop to term. The ethical debate is serious and ongoing. Questions include animal welfare, the moral status of chimeric organisms, and equitable access to future therapies. However, there is no verified evidence of secret facilities mass-producing hybrid beings for private organ harvesting. Current work remains experimental, transparent in peer-reviewed contexts, and focused on life-saving applications. Rather than a dystopian organ conveyor belt, xenotransplantation research reflects medicine's attempt to solve a real public health crisis while navigating complex ethical boundaries. Avatar projects, brain-computer interfaces, and robotic bodies. The idea of transferring human consciousness into robotic bodies remains science fiction. However, legitimate research into brain-computer interfaces, BCIs, and advanced prosthetics has made measurable advances in recent decades. Organizations such as 2045 Initiative have proposed long-term visions of creating robotic avatars controlled directly by the human brain. While ambitious, these concepts are speculative and not currently feasible. In practical terms, today's BCI research focuses on medical rehabilitation. Companies like Neuralink are developing implantable devices designed to help paralyzed patients communicate or control external devices. Similarly, advanced robotic prosthetics can already respond to neural signals, allowing amputees to regain partial motor function. The idea of transplanting a living human brain into a robotic body is far beyond current medical capability. Brain transplantation has never been achieved in humans. Even preserving full brain functionality outside the body remains biologically unsolved. Discussions about mechanical immortality therefore belong to the realm of futurism rather than present reality. Still, rapid advances in robotics, AI, and neuroscience raise profound philosophical questions about identity, embodiment, and the relationship between biology and technology. The real story is not about secret metal bodies waiting for billionaires. It is about how far neurotechnology can responsibly go in restoring function, treating disease, and enhancing quality of life, without crossing ethical boundaries that society is unwilling to accept. Gene therapy and CRISPR Rewriting DNA. Promise and limits. Gene editing has become one of the most transformative developments in modern biology. The CRISPR-Cas9 system allows scientists to precisely cut and modify segments of DNA, opening possibilities for treating genetic disorders that were once considered incurable. However, the technology is tightly regulated in most countries. Clinical gene therapies today focus on severe diseases, such as sickle cell anemia and certain inherited blindness conditions. These treatments undergo rigorous trials, regulatory review, and long-term safety monitoring. They are not cosmetic anti-aging injections, nor are they capable of granting biological immortality. Claims about secret offshore clinics routinely rewriting telomeres for the wealthy are not supported by verified scientific evidence. Telomere biology is complex. Artificially lengthening telomeres without precise control can increase cancer risk. Aging itself involves many intertwined biological pathways: DNA damage, cellular senescence, mitochondrial decline, not a single editable switch. The real ethical debate surrounding CRISPR centers on germline editing, altering embryos in ways that could be inherited by future generations. Following a controversial 2018 case in China involving edited embryos, the global scientific community responded with widespread condemnation and renewed calls for strict oversight. Gene editing is a powerful tool. It may significantly reduce suffering from genetic disease, but it is not currently a mechanism for creating a caste of biologically immortal elites. The scientific challenges remain enormous, and international regulation continues to evolve alongside the technology. Private space programs, escape or expansion. Private spaceflight has advanced rapidly in the past 2 decades. Companies such as SpaceX, Blue Origin, and Virgin Galactic have reduced launch costs, expanded orbital missions, and proposed long-term visions that include lunar bases and Mars settlements. Publicly, these initiatives are framed around exploration, scientific research, planetary redundancy, and technological advancement. The idea of creating off-world habitats is often discussed as a long-term species survival strategy in case of global catastrophe. At present, however, orbital stations and spacecraft remain extraordinarily resource-limited. Even the International Space Station depends heavily on Earth-based resupply. Closed ecological systems capable of supporting large populations independently for decades do not yet exist at practical scale. The notion of elite-only orbital arcs permanently abandoning Earth is speculative fiction. Space colonization faces immense engineering barriers: radiation exposure, psychological isolation, life support sustainability, and economic feasibility. That said, private space development does raise broader societal questions. If permanent space settlements ever become viable, who would have access? Would expansion beyond Earth reduce inequality, or replicate it in orbit? For now, space remains a frontier of innovation rather than an escape hatch. The rockets launching today symbolize technological ambition, not confirmed plans for planetary abandonment. The future of humanity, whether on Earth, in orbit, or beyond, will depend not only on engineering breakthroughs, but on political, ethical, and social decisions made collectively rather than privately. Immortality has fascinated philosophers, mystics, and scientists for thousands of years. What was once the realm of myth and alchemy is now explored through biotechnology, neuroscience, artificial intelligence, and space research. While no verified method of achieving biological or digital immortality exists today, serious investment is flowing into longevity science, life extension research, and emerging technologies that aim to push the boundaries of human lifespan. Unlike ancient rulers who built monuments to preserve their legacy, modern innovators are funding laboratories, medical trials, AI systems, and space programs. Some of these efforts focus on extending healthy lifespan. Others explore speculative frontiers such as cryonics or brain-computer interfaces. The motivations vary: curiosity, ambition, fear of death, or belief in technological progress, but none have yet delivered true immortality.